This biochemically defined model system of large unilamellar vesicles mimics the outer mitochondrial membrane to observe the function of BCL-2 proteins in vitro. First, combine the lipids and create a lipid film in a sealed vial. Then prepare fresh LUV solution and solubilize the lipid film. Next, extrude the lipid solution and purify the large unilamellar vesicles by gel filtration. The final step is to analyze the LUVs for a detergent-induced increase in fluorescence. Ultimately, the LUV model system is employed to evaluate the function and regulation of membrane permeabilizing proteins like recombinant BCL-2 proteins.
This approach using large unilamellar vesicles has several advantages over existing systems such as mitochondria. Since LUVs are generated with purified lipids in the absence of proteins, they are biochemically defined in both composition and in size. This allows for clear interpretations of the results, since the only proteins under investigation are the ones that you add.
This method can provide mechanistic insights into the BCL-2 family's ability to regulate outer mitochondrial membrane integrity. It can also be applied to other systems investigating membrane remodeling and permeabilization activity. This would include mitochondrial dynamic machinery or bacterial pore-forming toxins.
Working in a fume hood with minimal lighting, rinse a Hamilton gas-tight glass syringe with chloroform. Then, in a 1.5 ml amber glass vial, combine the 4 mg of chloroform solubilized lipids. Then, to remove the chloroform, apply